Okay, today's lesson should be really quick because we've talked about end behavior of a graph already. We know about the tails of the graph. So here we have the mama graphs from Algebra 1. We have the straight line, y equals x. We have the quadratic, y equals x squared, the cubic, and then our new ones this year. This is what a mama to the fourth would look like. This is what a mama to the fifth would look like, and a mama to the sixth. And we already know about end behavior. When it is an odd, we see the tails are one up and one down. One up and one down. And even linear, one tail is going up, the other tail is going down. Look at my evens. Two tails up. And we know that if we were to put a negative in front of them, so let's say we take this x cubed, and let's say we tried to get fancy. Whoops, we don't want to do that. Can't see that pen. And we said y equals negative x cubed. We would still have one tail up, one tail down, but the up would be first, and the down would be second. Because when we are negating the y value, you're like, wait a second, we're negating the x value. No, we're not. We're negating the y value. Because if we solve this for x, the negative would be on the y. And when we negate the y value, we flip everything over the x-axis. So all you're learning today is a function whose highest degree is odd will have end behavior as one up, one down. Even will have both up, or I should add on here, both down if the leading coefficient is negative. So n to an odd will look like this. Negative n to odd will look like this. N to a highest even will look something like this. N to a highest even with a leading negative will look like that. And again, how many zeros are in the middle depends on how many relative minima and maxima there is. So all we want you to be able to do is to quickly match and recognize polynomials. This is all about looking at a graph, analyzing as much as you can quickly, and then getting into the deeper stuff in calculus. So for example, I can sort all this. I can say, okay, you got a tail up, you got a tail up, you got a tail up. You're all my even graphs. You're all my ones raised to an even power. Because an even graph and an odd graph, that's a whole nother thing. So let's get that straight. So you're raised to an odd power, you're raised to a highest degree of an odd power, you're an even highest power. Ooh, you're an odd, you go over there. Even, even. All right. So I'm just going to put these over here for now. Let's get to the even. X squared, x to the fourth, x to the fourth. Well, this says, remember to check for clues like y-intercepts and the strength of the leading coefficient. Well, when I look at these two right here, you should know that the y-intercept is 2. Because if we put 0 in for x, all that's left is 2. So we know that that means, let's see, you've got a y-intercept of 2, and you've got a y-intercept of 2, And you've got a y-intercept of 0, 0. So boom, here's our first matching one. This is the graph y equals 1/2 x squared. Now, which one goes with these other ones? Let's bring that order to the front. That's where we look at the leading coefficient strength. This has a leading coefficient of 3. This has a leading coefficient of 1. If I have a leading coefficient of 3, if we remember again from 8th grade, that means we're stretching our end tail behavior and making them very tall and very skinny. So looking between these two graphs right here, who is tall and skinny? This one. So this has a leading coefficient stress of 3. And then that one leaves that last matching. Now you may be saying, well, why can't we do this on a calculator and just match it up? Well, you can, but come on, you can figure it out just by looking at it. All right, so for this one, I got x to the cube, x to the cube, x to the 5th. They're all highest degree of odds, and yes, one tail up, one tail down, one tail up, one tail down. No leading negatives, but let's again look for those y-intercepts. Okay, so this has a y-intercept of 2. This has a y-intercept of -8. This has a y-intercept of 0. This is easy. All 3 y-intercepts are different. All right. Who's got a y-intercept of 2? You, down here. Who's got a y-intercept of 0? You. And who's got a y-intercept of -8? You. Pretty simple. Notice with x to the 5th also that we've got some relative maxima and minima going on, because we know that it could have been a possible 5 times crossing the x-axis. Notice the difference also between this x to the cube and this x to the cube. Look at their leading coefficients. This has a leading coefficient of 1. This has a leading coefficient of 3. So think about you holding the end of these graphs and tugging. And that's why this is more narrow. This second graph right here is more narrow than this first graph because we have a tugging of 3 going on.